All right, hello and welcome to Risky Business. I just forgot to cycle the recording, so I just did that. So yeah, like I was saying, I had some networking issues earlier, but fingers crossed that it's fine now. So we'll see. But I think it's good now. So let's go to the Milton folder. Alright, so this is where we left off. And we were confused with the coordinate conversion. Our mental model is not lining up with reality here. So over the weekend, I kind of, I didn't really try to think about this because I want to do it all on stream. But of course, it was in the back of my head. And one thing did occur to me that we might want to look into. I'm thinking that this vector that we drew, perhaps it's pointed the wrong way. I feel like that would make sense. So we're going to investigate that today and hopefully get our mental model of this sorted out. Hello, Miblo. Oh, let me, there we go. Hello. Congratulations on successfully annotating Handmade-Hero Day 354. So we are trying to correct our mental model here of the coordinate conversion. So I believe it is time for us to put on our thinking caps. All right, and let us take a look here. So is the eraser? There it goes. Okay. So I'm thinking the problem is that right there. Yes, you like the thinking cap? I thought that would be a nice touch. So I'm thinking that our problem is that the pan vector is going this way, not the other way around. And maybe it's not from the origin. That would be possible too. Is the thinking cap a little too distracting? So let's see where our little calculations are. So it looks like we were doing our little math over here. So we're going to try it again and just see what happens with the vector going the other direction. So if the vector is pointed the other way, I believe that would mean pan vector is just -2, -3, right? Because we're going up 3 and to the left, or up 4 and to the left 3. So, let me erase what we had here. All right, so we have a point that is 3, 4 in canvas space. And we're going to say our pan vector this time is -2, -3. So essentially what this becomes is 3, 4 plus -2, -3, which would just be minus 2, 3. And then it would be that divided by the scale plus the center. Now, the other thing I'm wondering about is this plus center part here. I feel like intuitively when I'm converting the coordinates, intuitively I'm not doing anything like that. So I'm not sure where that factors in right now, but we're going to find out. So this, of course, would just be 1, 1, I believe. So then we're saying that divided by 0.5, which is times 2, so that would be 2, 2. And then we add the center. So we can see that this is still definitely wrong. So our center is 6, 4. So that would give us 8, 6 as the point in raster space, and intuitively we know it's supposed to be something 2. We didn't calculate the x, but I think it would be like between 1 and 2, like 1.5 or something like that. So we're definitely still wrong, but at least we're going in the right direction. Because where we left off the last time I streamed, the formula here was putting us completely off the raster somewhere out here, and the point is right here. So we were very wrong before, and now we're just slightly less wrong. So we're making progress. So I want to take a look at what I'm doing intuitively, because I can just like think about it intuitively and get what I'm positive is correct. And whatever I'm doing intuitively is definitely not the formula we're working through here. So what am I doing intuitively to calculate this? So I'm saying the point is 3, 4. So we have our canvas space here. These axes represent the canvas space. And then we have these markings, and I'm just saying each one is a unit, right? And I came up with a contrived, this 12.8 over here. This is our screen dimensions, which is very contrived, of course, but I picked these numbers because it works out nice, right? So this is our screen, this little rectangle here. And we have the screen origin here, and then this is the canvas origin over here. And so in terms of screen space, this point, this screen origin would be 0, 0. And so we know that the screen origin is at 2. Wait. See, now when I erased, I erased some of these markings and I put them back in. And so I was saying this is at, according to this, the pan vector is -2, -3. So you can see it's 2 over on the x-axis, but I have it drawn here 4 over on the y-axis. Yeah, I put in one too many markings, so let me redo the y. So that might be part of our confusion. So we have a marking here, and then that's supposed to be 3 right there. So we're gonna say there's one here and one there. So now our pan vector is 2, 3. So what I'm saying is the origin in canvas space is 2, 3. So intuitively what I'm doing is I'm saying, okay, we have our point that is 3, 4, but if we just count in like from the origin as 0, 0 and say where is it in relation to the origin, right? I can say, well, it's 2 units over from this 0, 0 point. So wait a minute, 2, no, it's 1 unit over. My drawing skills are confusing me. But yeah, it's 1 unit over. This is supposed to line up with this. This lines up with this. Because it's 3, you can see, so this is 1 unit over this way, and then it's I think just 1 unit this way too, right? Yeah. So what I'm saying is for the y-axis, we know that this is in the center of this quadrant right here. So because this is like the height we have is we start here and then it's 1, 2, 3, 4, right? Because its scale is 0.5. We know that our total height is 8. So we have 4, and then half of that is 2. And this, we're saying this point is at 1 down from the origin, which is halfway between the midway point. And so we know when we multiply it by the scale, which is times 2, or divide by the scale of 0.5, which is multiplying by 2, we end up with 2 for the y-axis, and then we just basically do the same thing on this axis as well. And so would it actually be 2, 2 then? Well, let me see. What's the width here? So we have 1, 2, 3, 4, 5, Is that right? Yeah, because it's 12, so it's half of that, right? And so half of that is 3 over here. And so it's not directly in the center over here, because we're going from here to here, basically. And we're saying it's right there. So it's 1.25, right? Because that's a fourth, isn't it? Or no, that's a third. So it would be 1.33, I think. 1.33 repeating. So that's intuitively what I'm doing. Now I need to put those words into a actual mathematical formula. So what exactly am I doing? Well, I'm saying, first of all, we're putting this point, instead of being relative to the canvas 0, 0, we're making it relative to the origin. Rupan, is that the risc-v thing related thing on Hackaday? I saw that on Twitter, I think. I haven't looked at it yet. I was gonna take a look at that after the stream is over today. But thank you for the link, if that's what I'm thinking it is. I'm definitely gonna take a look at that. Or is that something else? Either way, it looks interesting. Just from the URL. But anyway, so I think to put it relative to the origin, that would be subtracting, right, the pan vector, or adding the negative pan vector, as it were. Because when I do that, I get 1, 1, which is what we drew here. These little dotted lines are saying that it's 1 away from the origin in on each axis in canvas units. So that part lines up with what we were doing, right? Because this is the same as saying pan vector plus point if the pan vector is negative, and then like -2, -3, you just rearrange it and it's the same as this. So I think that much is right, but it's what we're doing from there that's wrong. So what am I doing from there? I am saying, well, do I actually use that though? Yeah, I do. Because I'm saying, I'm taking in the y-axis, we said that it's it's 1, and then we have the total, which is 6. Now, what exactly are we doing with those two values, though, to get the final result? Like, intuitively, isn't it just like 1/6? Because we're saying we have 6 units on the wait, not 6. It's 4 units on the Y. So here to here, that's 4 units, right? And so we're saying 4 units. So it's 1/4 of the total height is what this is saying, right? And then from there, we take it times the actual height. So the actual height is 8, right? So we're saying 1/4 of 8 equals 2. I'm pretty sure that's what we're doing. And then the same thing for the width. So we're saying 1/6, and then we're saying times 12. So 1/6 of 12 is how much? And I was saying I think it's like 1.33 or something. Wouldn't that just be 2? 12/6, that's 2, isn't it? I mean, I'm not the best at math, but I think that's just 2. I guess that makes sense. Now that I think about it, that it would be 2. So that's just this value over here, isn't it? So I think what I have in my mental model of what screen space is supposed to be, I see it as the result would be 2, 2. And the way we're getting that is just this part right here. Wow, that's really bad. Someone commented on YouTube asking if I write with a mouse. And I see why you would think that, because my skills here are pretty poor when it comes to writing, but I am using a tablet. Believe it or not. So my understanding then is that what he is defining as screen space is just offset by this center. and I don't know why. So essentially, if I'm understanding everything correctly, and I'm right that the center is the 6-4, then he would say that the correct answer is 8-6, and I'm saying the correct answer is 2-2, because I'm thinking of this much as being logically what screen space is, and he's saying it also is plus this. And I'm confused because I don't know why you would add the center. That doesn't make sense to me at all. Because like the 2-2 value, if we have a 12 by 8 pixel screen, 2-2 is the actual like pixels that you would go to draw that point in the right space. So I'm really confused about this plus center business. I'm wondering if maybe he's defining the pan vector, because we don't actually know for sure what pan vector is. I'm just making an assumption here that the pan vector is from the origin of the screen to the origin of the canvas. But maybe I'm wrong about that. He's actually saying the pan vector is like by the center, which would maybe explain why we're adding the center over here or something. Something like that is kind of what I'm wondering. It's too bad he's not in the chat today, so we could just ask him. So I wonder if we search in the code a little bit. I'm wondering if we can get some hints to what the pan vector actually is. So nothing is really like standing out to me as like telling us what the pan vector is in relationship to. We have this comment here that says it's in the canvas scale, but we already knew that. We already saw that and understood that. The thing we're wondering about is if we draw the arrow that the pan vector represents, like, where do we draw that arrow? That's the part that we're confused about. Because I know that if you draw it as I've drawn it in this diagram, we can get an answer that makes sense by doing this much. But I'm thinking that the reason we're adding the center is because that's not what the pan vector is. That's like the only reason I can think of that you'd add the center. Because what else could be wrong about what we're doing? Everything else makes sense. So we have the scale, which is the zoom. So I don't think we're doing anything wrong with that. We know that the center is the screen center in pixels, which is a pretty specific thing. And we know that the pan vector is in the canvas scale. So the only thing that I could see that would make it so that you need to add the center is if the pan vector is something else. So I think what we need to do now is try a different pan vector and see if we can get a pan vector that makes more sense, where in such a way that you would actually add the center at the end. So I think the first thing I want to try, because we're adding the center, it kind of makes sense to try from the center. So this guy right here. So what is our center in canvas? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to say our pan vector is -5, -5 now. So what happens if we do -5, -5? So this becomes -2, -1, right? And then if you add the center back to that, that becomes or wait, we need to multiply by 2. So it would be, if we have -2, -1 multiplied by 2, that becomes -4, -2. And so we add that, which gives us 2. And we add 4 to the y, which gives us 2. So I think it works out in this example. I don't know if it works in general, but I have a feeling it does. It makes a lot of sense. At least to me, it makes sense. I don't know about the people watching in the chat, but I feel like we figured it out. This seems right to me. It's all the pieces have come together, and we have a vision that makes cohesive sense as a whole. So this is what I'm thinking. This is the pan vector. It goes from here to here. I don't know, insofar as I thought Thought everyone was taking careful notes here. So this is the pan vector. We have a point that we're passing in that we want to convert. We divide it by the scale. Then we add the center, which is just adding the center is just translating from having this pan vector to having that pan vector that we were looking at before. So if you just do this much, that would be if our pan vector is from the origin. But if we do this, we're saying that we have a pan vector in the center. So I think I understand this now. I think I understand this. So we're going to say this is from screen center to canvas origin. Now that we have an intuitive understanding of this, I think we're ready to start thinking about what we actually need to implement. So I'm going to move this over here. And now what we want to do is have, I'm going to draw another one of these diagrams. So this is canvas space again. And so basically what we're going to do is we're going to draw, like, this is, we're not actually going to draw this, but like logically what we're doing is like we're going to have a line here and then like skip some amount of units. We're just going to like skip 1 unit for this. We're going to say there's a line going across here, and it goes, you know, infinitely long. There's another one here. Another one here. So you get the idea, right? It's an infinite like grid of lines. And then once again, we're going to put in a screen. So I'm just going to say like, this is our screen right here. And so we're seeing lines going across at these points. So there's our center. Now, essentially what we're going to do, I think it should be pretty easy to draw a line. Like, if we were just working in screen space, like say we know what this point is, and we can figure out what this point is trivially, right? Then you just draw a line right there. But it needs to actually be relative to the canvas because we want the lines to move with the canvas. And then I also have ideas about what we're going to do in relation to zooming in and out as well. But that's, that's another topic. Right now we're just focused, we're breaking it down into small parts, right? So right now we're just focused on drawing lines in relationship to panning. So for simplicity, I'm saying we start at the origin and we go like some amount in each, this direction and this direction. And, skip so many units, draw another line, skip so many units, draw another line, just in repeat. And so what we need to figure out, basically what we're going to be calculating is, what is this distance right here? Where do we draw the first line? And then how many lines do we draw? And then we need to, of course, calculate each of these points. And then do the OpenGL calls to actually make this happen. So there are a few interesting things to consider here. First of all, I want X pixels between each line. So this is in terms of the spacing of the lines, I'm thinking about it in terms of screen space, in terms of the raster space. But in terms of positioning the lines, I'm thinking about it in terms of canvas space. So that's kind of why I knew we need to get an intuitive understanding of the conversion stuff. Because there's definitely going to be conversion stuff happening here. So what else? We want to have a clever way to figure out where we start drawing on the screen without like actually looping over, an infinite space of lines. An infinite loop would take a large amount of time. So we want to do something a little bit more clever. So for now, we're going to simplify the problem and think about the space between lines in terms of canvas units. And we'll figure out the translation to get like so many pixels between lines later. And then it's going to get even more complicated when we do zooming. But so we have this vector here. This is our pan vector. As we just figured out earlier. Now, so here basically we're saying we skip every other unit. So we're saying there's every 2 units there's a line in canvas space. And so basically what I'm thinking is I want to think in terms of the origin, just because that's easier for me to wrap my brain around. So if we go from the screen origin to here, what was I thinking? I had a thought and I lost it. So well, basically, if we know the distance on the y-axis from the origin of the canvas to the origin of the screen, and we know the distance between lines, then we should be able to figure out where to place the lines. So we're going to say, for this example, we're going to start putting in actual units and figure it out from there. So we're going to say so we know this is 2, right? And this value here is going to be, I'm going to say the screen goes to here, so that's 1, 2, 3. So this is 3. And we know that it's a multiple of 2, so that's like a modulo operation, right? Like one of those bad boys. So intuitively, we know that the place we need to start drawing lines is going to be at 1 right here from the origin, because it's 3 units down and there's 2 units between lines. But it's not just a subtraction, right? I think we actually want some kind of modulo business in there. So I have kind of an intuitive, like, vague view of this space, but I don't have the concrete, mathematical formula here that we're trying to do. like in this particular case, it's just 3 minus 2, right? Gives you 1, but I'm pretty sure that's not the general case. That's how you do it. Because like, what if we're above the origin, or if we have different values, you know? So is it just like 3 mod 2 or something like that? So where's my phone? I want to do a little mathy stuff. What is 3 mod 2? Is that not the right operation here? That doesn't look right. Let's do it on Google. So let's say 3 mod 2. So that's just 1, right? That's what I was thinking. Now, is that the general answer, is what I'm wondering. I'm not 100% sure about that, but it feels kind of right. It feels kind of right. So for now, we're going to assume that that's correct, and we'll revisit that in a little bit. The next thing we need to know is from there, once we figure out where we draw, once we know where we start drawing, we need to figure out how many lines we're going to draw. So we could just like loop and stop when we're off the screen. Or we could pre-calculate the amount we need to draw for where this screen currently is. I'm trying to think which would be better. I feel like we might as well just loop, like do a while loop, right? And not worry about pre-calculating. Because we want to do as little work as possible, right? And so if you don't need to calculate something, maybe you shouldn't calculate it. That is my argument. So I think we don't need to worry about that. The only thing we need to worry about right now is making sure this is the correct formula. So essentially, let me write out the proper formula for what we're trying to do here. So I'm saying, excuse me, I think it's like screen origin in canvas space. And then we're going to say that minus well, we're going to say screen origin dot y, because we only care about the y-axis. And then it's minus the canvas origin, which is just 0. So it's like this number here. And then we're saying mod this number here, which is space between lines in canvas space. And I'll just put a Y in there. So I think this is kind of what we want. Maybe, maybe not. And the way to figure that out, I think, is to just try a bunch of cases and see if it works. And if it doesn't, we know we're wrong. But I still want to just assume that this is right and take it to the logical conclusion. So we have I think we can probably get the screen origin in canvas space without using the pan vector. I think let's just take a look in the code. So not exactly. We don't store the origin. We store the screen size, the scale, the center, the pan vector. So we do need to calculate where the screen origin is, I guess. Not exactly. We don't literally need to calculate the origin. We just want to calculate this like distance. So we can get this distance easily right here, because that's just one of the components of the pan vector, right? So we know this value. In canvas space. And we know that this distance right here is 1/2 screen height so then this distance right here is pan vector dot y minus 1/2 the screen height. Now, is there a convenient way to say that? Because like we have screen center in pixels, and we have screen size also in pixels. So we don't actually have a value within canvas view of the screen height in canvas space. So we are going to need to do a conversion here. So I think the easiest one to do would just be so it would be raster to canvas, and I want to know screen center dot y. Now I think the actual raster to canvas function doesn't take scalars. I think it takes vectors, but we'll worry about that later. This is the general idea of what we're doing. So that gives us the that value right there. And then we need to take the mod of that with the space between lines in canvas space. So we're saying we're going to define the space between lines in terms of pixels, right? Because what I literally want to do is like take a piece of notebook paper and say like, okay, this is like so much distance between lines, and I want that to match on my screen with default zoom. And so we're going to define that in pixels. I don't want to try to do like pixel to like meter conversion or anything like that. I'm just going to eyeball it. But I think pixels is a reasonable unit there. So then essentially what we should do is define that as like a vector from the origin, so we can just do raster to canvas and then we'll say it's like line spacing dot y. I think we want to do something like that. So now we have something concrete, I think, that we can try to implement and see how it works. But I think we're going to want to start simpler than that. We're going to start by just like drawing a line on the screen and getting that working, because I don't know OpenGL. So we're just going to figure out, how do we use OpenGL to draw a line on the screen? Once we know that, we're going to do what we just whiteboarded out right here to get the appearance of notebook paper. And then we're going to do another whiteboard session where we whiteboard out all the plans for making this work with Zoom as well. And yeah, meters might be a little bit overkill, but it would actually be nice to have like pixels to centimeters or millimeters or something like that. I know some programs like GIMP do that, but I think that would be overkill to implement something like that. And also we are out of time, so I believe we are going to need to call it a day. And next time we're gonna jump into the code and actually start drawing some lines on the screen. So thank you everyone who watched today. As always, it's very much appreciated. And thank you to everyone who watches on the YouTube archive, which is available at risc-v, just a convenient way to get there. And if you want to catch one of the live streams, head on over to @HMN_risky on Twitter, where you can find updates every day about when I'm streaming. So I believe that's it. So stay risky, everyone.